we're going to take a look at our last example of being able to plot a slope field, plot a solution to a differential equation, and then also on the same graph, and also solving the initial value problem. So in the last video, we took a look at this fairly simplistic example. Let's go ahead and take a look at this a little bit more difficult example. And there's really only a little bit of syntax difference. So what I did was I just kept the exact same code from the previous example. And I'm just going to change this to 0.2 because 0.2 is a fairly good starting point. The domain's the same. Now, this is going to be different. So the y prime is going to be equal to, now we have to be careful with this. It's going to be 2 dot times x plus 1, all right? And the reason that is because the mesh grid is a row vector of x and a row vector of y. The other thing that we have to be careful of is we have to do dot divide, all right, because we're performing a division operation on each of the different elements in the array, all right? And then it'll be 3 dot times y plus 5, all right? So that's one thing that we have to be aware of, is that if we have any multiplication or division within this mesh grid function with the y prime, then we have to go through and change this. Now, the other thing that we're going to have to change is we're going to have to change the solution. All right, so what I'm going to do is get rid of that. And all I'm going to do is just copy and paste this code for the y prime. And I'm going to use that as my differential equation. So diff instead of x plus y from the previous problem is going to be equal to 2x plus 1 divided by 3y plus 5. The initial condition was y at 1 is equal to 1, so I have to change that as well. So we're just going through and making sure things match up. All right, so just be careful when you're changing these. And it's going to give us our solution. Right, so here's our solution right here. 6x squared plus 6x plus 52 times 1/2, square root of that, 5 by 3 minus 5 thirds. All right, so I'm going to take this, and just like we did in the previous, I'm going to take this solution, I'm going to copy it, and I'm going to paste it right where f is, but I'm going to change all the lowercase x's to capital X's. And I don't need to do the dot times for this because I'm going to use easy plot, all right, symbolic, right? Everything else is good to go. All right, so let's take a look and see what this looks like. And then from there, we can go ahead and change these inner parameters of the sizes of the vectors if necessary. So I'm going to execute this. All right, and the good news is that we get a fairly nice vector field. The vectors might be a little close to one another, and then the solution looks like it's going right along the slopes of the curve. All right, so that's good. Now let me change this to a 0.4, and if it's too much, then we can go ahead and do 0.3. And that looks like a pretty decent description. So I can clearly see what the solution curve looks, or the vector field looks like for this, or slope field in this case. And we can clearly see what the function solution looks like. So the good news is that once you get it to work for one of the problems, then the rest of it is just going through and cutting and pasting to make sure that you can do the other types as well. All right. So hopefully this is helpful for you to understand how to use MATLAB overall. And also how to use MATLAB to be able to solve differential equations that are fairly well behaved, but then also to be able to graph the slope fields to find the solutions of an initial value problem, and then to be able to graph the slope field as well as the solution to the initial value problem on the same graph.